Okay, section 6.5. The title of this is called Rhombi. That's how you pronounce that, rhombi, and squares. Well, that word rhombi is kind of weird, but it's the plural version of the word rhombus. And here is the definition of a rhombus. A rhombus is a singular, one of these things. A rhombi is if you had two or more. That would be plural. So that's why they call it rhombi, because they put squares, so that's plural, so they made that plural. Anyway, a rhombus is what? It's a parallelogram, just like this whole chapter has been talking about. It's been talking about parallelograms, but it's a special type of parallelogram that we haven't really discussed yet. So it's a parallelogram. So all the stuff that's true about a parallelogram is true about a rhombus. But what's a little bit more special about a rhombus? It has all four sides congruent to each other. So here's what a basic rhombus would look like. Let's make this a little bit bigger. Now, I don't think I have this measured out exactly. I probably should have one and taken the time to make sure it's exactly the same. But I think we can deal with this. If not, oh well. We're just going to have to deal with it. Let's see what I want to do. I want to mark this thing. So we don't have any special kind of a symbol or anything like that for rhombus. Remember, it's a parallelogram, so I could just I can go A, B, C, D on this if I wanted to. Now remember, everything that's true about a parallelogram is also true about a rhombus. So that means the opposite sides are both pairs of opposite sides are parallel, both pairs of opposite sides are equal, both pairs of opposite angles are equal, the diagonals bisect each other. All that stuff is true about a rhombus as well. Why is all that true? Because it's also a parallelogram. So everything that's true about a parallelogram must be true about a rhombus. But the thing that's special about it is all four sides are exactly equal to each other. That still works with that one theorem where it says that both pairs of opposite sides are equal. See? They're equal and they're equal. So it still works. But this goes a step further and says that all four sides are equal to each other. And that's the definition of a rhombus. Now, there are two theorems. Lost my train of thought there. There are two theorems that deal with the diagonals of a rhombus. So let's take a look at those two theorems. So here's a rhombus, and let's draw its diagonals and see what it looks like. So remember what a diagonal is. It goes from one corner to another. And to here. And let's take a look. Look at the diagonals. It sure looks like it, doesn't it? Right there. I'm not going to go through any proof or anything for it. Just trust the theorem on this one, I guess. And so that's what's true about the diagonals of a rhombus. Okay, they are perpendicular to each other. So let's put some letters in here, A, B, C, D again. And we'll put an E right in here. We'll use that in a second. So I could say that DB is perpendicular to AC. All right. Pretty simple stuff. It's just something you have to remember. Now, that's only true when it's a rhombus. Remember, when it's a rhombus, all four sides are equal to each other. That's only true about a rhombus. It's not true about a regular or parallelogram. If you drew the diagonals of a regular parallelogram that's not a rhombus, that doesn't have all four sides equal, these diagonals, they'll bisect each other, right, because that's one of our theorems, but they won't be perpendicular. The only times they're perpendicular is if this thing is a rhombus. Let's look at another theorem. All right, look at this theorem. It says if a parallelogram is a rhombus, so this is a parallelogram and it's a rhombus, which means, again, the opposite sides are equal, they're parallel, the diagonals bisect each other, all that. And it's a rhombus, so it's also true that all four sides are equal to each other. And it also talks about the diagonal. So both these theorems deal with the diagonal. It says this one says the diagonal bisects a pair of opposite angles. So let's draw the diagonals again. Remember, it goes to a non-consecutive vertex. We talked about that in another lesson. So there's a diagonal, and there's a diagonal right there. Now, we know they're perpendicular because of that other theorem we just talked about. But here's another thing that's true. This is a little bit different. Now, if you remember, on a parallelogram, angle Q would already equal angle S. Because remember, opposite angles, or both pairs of opposite angles, are equal to each other. And this big angle P, this whole entire angle P, and this whole entire angle R, they would equal each other as well. Now, here's one thing that before this lesson, you might have had a tendency to think this was true, but it wasn't true, unless this thing is a rhombus. Now here's what it says. Each diagonal bisects a pair of opposite angles. What does that mean? That means that here's the opposite angles, S and Q. This diagonal bisects both of these angles, S and Q. That means that this angle and this angle are going to equal each other. Now remember, angle Q and angle S, the whole entire angle Q and this whole entire angle S were equal to each other. So if this angle was bisected, for instance, let's say angle Q is, I don't know, 60 degrees. And if I bisect it, that's going to be 30 and that's going to be 30. Well, if angle Q is 60 degrees, angle S would be 60 degrees. And if I bisect this 60, then this would be 30 and this would be 30, just like up here. So here's what's true. If this is a rhombus, all four of these angles would be equal to each other. All right. Now, it doesn't mean that these four angles are equal to these four angles right here. Because look, this is obtuse, this is acute, so there's no way that they're going to be equal to each other. But we do know we can do this. All right, so remember these opposite angles right here, the diagonals bisect a pair of opposite angles. So that's opposite angles right here, here's opposite angles right here, and they're going to all be equal to each other. Remember, because these two angles, big angle P and big angle R, would equal, and if they're both being bisected, then all four of these angles that are made up must be equal to each other, congruent to each other. It's a lot of information, okay? It's not hard to understand, I don't think, but it is a ton of information that you got to keep straight. Let's go through the rest of this. Since it's a parallelogram, all right, since this rhombus is a parallelogram, all the other stuff must be true about this. This and this, this and this must be equal because that parallelogram is a rhombus, so all four of those sides are equal. Both pairs of opposite sides are parallel. We already talked about the opposite angles being equal. What else is true about the diagonals? Well, it's perpendicular, all right, because of the last theorem we just talked about. But also, let me do this in another color. Also, remember the diagonals bisect each other. So this and this will equal, and this one and this one will equal to each other. Doesn't mean the diagonals are equal to each other, but the diagonals do bisect each other. Wow, there's a lot of stuff. And there's other things too, like the consecutive interior angles are supplementary. All right, that's good information right there. I can't think of anything else that might be true. There might be something else that's slipping my mind, but that's a lot of stuff that's true about a rhombus. Okay, now remember, a rhombus, all four sides are equal to each other, and it's also a parallelogram. All right, let's move on to something else. Let's do this example before we move on to something else. And yeah, we got to talk about a square after this. Let's do this real quick. Angle FJH. FJH, that's this big angle right here. That big angle right there is 82 degrees. All right, let's not talk about the big angle though. Well, I tell you what, let's just do that. Let's put that arc right there, and that's 82 degrees. We want to find KHG. Let's find that. KHJ, I should say, not G. KHJ, this angle right there. That's what we're trying to find. We're trying to figure out what that angle is. And they kind of tell you something here. They say this big angle right here is 82 degrees. But I'm not going to use that whole 82 degrees. What am I going to do? Well, if I want to find this angle is part of this triangle right here, JKH. Do you see that triangle right there? And I know another angle in here. I know this is 90 degrees because it's a rhombus. They tell you, by the way, I should have told you that it was given that this was a rhombus with diagonals in a rhombus, okay? So if this is a rhombus, the diagonals are perpendicular to each other. I'm trying to find this angle, and I actually know this angle right here. Remember, I was told this whole thing is 82 degrees, so this angle right here would be 41 degrees, because remember, the diagonal bisects that angle J. So if the whole thing is 82, that would be 41. If I wanted to, I could put a 41 here as well. That's 82 degrees. Now all I got to do is find this. So how do I find that? Basically, I just go 90 minus 41. Okay, that's a 9, and that's a 4, so that would be 49 degrees. And that's all there is to that part of the example. Pretty simple. This is a pretty simple one too, okay? This time we're going to talk about the line segments, okay, not the angles. So let's mark the stuff on our picture right here. GH is x plus 9. So here's GH, and I'm going to put x plus 9. That's the length of that segment. JH, this one right here, is going to be 5x minus 2. Now remember, they told you that this is a rhombus, and we just have to solve for x. Couldn't be much easier than this. Remember, on a rhombus, all four sides are equal to each other, so these are two sides of the rhombus, so what do? Just set them equal to each other. No big deal. And let's just do the math. Subtract x from both sides, add a 2 to both sides, and x is 11 over 4. And it's perfectly fine if you just keep it 11 over 4. If you wanted to, you could make it, what, 2 3/4 or 2.75. But why bother go through that? If it was me, I would just keep your answer like that. That'd be perfectly fine. No big deal. So they just say solve for x. They don't say solve for the missing side, but they could. On a quiz or a test, I might ask you, say, find the length of JH or find the length of GH or something like that. Okay, and you should be able to do that. Take that answer, plug it back in, and you've been doing that kind of stuff all year long. All right, let's talk about squares here for a sec. Okay, here's the definition of a square, and I put a square right here. It says a square is a parallelogram, just like we talked about before. So remember, all the stuff that's true about a parallelogram is true on a square. Opposite sides are parallel, opposite sides are equal, opposite angles are equal, blah, blah, blah. All the stuff that's true about a parallelogram is also true about a square. But you got some other things here. It says with four congruent sides. Well, we just talked about something, a parallelogram with four congruent sides. That was a, what? A rhombus. So a square actually is also a rhombus. So if everything that's true about a rhombus must be true about a square as well. So we talked about diagonals. The diagonals are perpendicular. They're also perpendicular with a square because a square is a rhombus because of that part of the definition. But here's a little extra part that's not true about every single rhombus. It also has four right angles. That's what makes it a square and not just a rhombus. So a square is basically a rhombus with four right angles. And I'll just put those in here. So that's what a square is. Now remember, a rectangle, we did the definition of a rectangle, I think the last lesson. It said a rectangle is a parallelogram with four right angles. So look what a square is. A square is kind of a combination of everything. It's a parallelogram, it's a rhombus, and it's a rectangle. So all the stuff that's true about a rectangle is true about a square. All the stuff that's true about a rhombus is true about a square. And all the stuff that's true about a regular parallelogram is also true on a square. Wow. Such a simple little figure, a figure that you've probably seen since you've been a little kid, and even knew the name of it probably since you're a little kid. But there's so much involved in a square, it's hard to believe. So let's do what first? I thought there was going to be like a special theorem or something, but basically what I said, if you know all the stuff that's true about a rectangle, a rhombus, and a parallelogram, that's true about a rectangle. Let's just run through some of these just so that we remember. So here's, I'm going to write a couple diagonals, draw a couple diagonals on this thing. Now remember, the diagonals bisect each other because it's a parallelogram. They do this right here. They're perpendicular to each other because remember, a square is a rhombus. The diagonal, since it's a rectangle, the diagonals are actually equal to each other and they bisect each other, which means all four of these are going to be equal to each other. What about the angles right here? Look at this. Remember, since it's a rhombus, the diagonals bisect the opposite angles. So if this was 90 degrees right here, if I bisected it, that is going to be 45. So I know on any square at all, if I draw the diagonals, I'm going to get a 45-degree angle. Look, that's 45. That would be 45, 45, and so on. I'm not going to draw them all out. Okay? You know the opposite sides are parallel, all that good stuff. And you can also look at it as a triangle. Look at this triangle right here that I shaded in. This triangle is going to be congruent to all four. All four of these triangles are going to be congruent to each other. Man, we can go on and on about all the stuff that's true about a square. And I bet you when you're a little kid, you had no clue that all that stuff was true about a square. You probably didn't care either, but that's all right. Now, hopefully we care a little bit more. Maybe, maybe not. But there's a ton of stuff to know about a square. It's not difficult. It's just a lot of stuff. All right, let's go on and look at something slightly different, but kind of the same. This theorem kind of looks familiar. And we've done this over and over again. This is actually the converse of that first theorem that we talked about. Look at the difference. It says if the diagonals of a parallelogram, so we start off with a parallelogram, are perpendicular. Okay, so we know this is a parallelogram. We don't know that it's a special type of parallelogram, but we know it's a parallelogram. And if we drew the diagonals, and if they just happen to be perpendicular, then what kind of parallelogram, what kind of special parallelogram is this going to be? Well, then it will be a rhombus. Do you remember before they started off saying this parallelogram was a rhombus? What must be true about its diagonals? They must be perpendicular. This switches it around. This takes if P then Q and switches it around to if Q then P. And we've discussed that. Hopefully you know what I'm talking about there. So it's kind of the same thing, except they start off with different given information. They give you, okay, that is a parallelogram on both of them, but on this one they say that the diagonals are perpendicular. They tell you that right off the bat. Then what can you say about this whole entire parallelogram? You can now say that it's a rhombus. So if you know the diagonals are perpendicular, then you know that this is a rhombus. Here's another converse of a theorem that we learned just a little bit ago. It says if one diagonal of a parallelogram, that's why I just drew the one, bisects a pair of opposite angles. So here are opposite angles. I've split it right here. And if they bisect the opposite angles, so if those two are equal, if 1 equals 2 and if 3 equals 4, if that's true, then what kind of figure is this parallelogram? Then it's a rhombus. Now, I didn't actually have to put 2 arcs here. Since I knew it was a parallelogram, I knew both of these angles were equal to each other, so if it bisected both of the opposite angles, all 4 of those angles must be equal. So I could very well just put 1 arc for all of those to show that they're all 4 equal to each other. So this is a converse of the theorem that we had before, because remember what it said before, we started off knowing that it was a rhombus. We said, okay, if I know this is a rhombus, then I know that the diagonal bisects both of these opposite angles. But this time it says, I don't know it's a rhombus, but I do know that the diagonal bisects both pairs of opposite angles. If that's true, guess what's true about this whole thing? This whole thing must be a rhombus. Okay, very similar to what we did before, just using the different theorem. We have another one to look at. This next one's kind of interesting because it's not really a converse of another theorem that we've talked about, but it should make a little bit of sense to us. Let's read it. It says, if one pair of consecutive sides, what does consecutive sides mean? Consecutive sides means the sides that are right next to each other, okay, not the opposite sides. These two sides would be opposite. This side right here and this side right here would be consecutive, or this top one and this side one would be consecutive. So it says if one pair of consecutive sides of a parallelogram, so I'm given that this is a parallelogram, if they are congruent, which means what? It means this side, what's a consecutive side? I could either pick this one or this one, doesn't matter. Let's pick this one. So if I have one pair, just one, okay, I don't have to have both of them, just one pair of consecutive sides of a parallelogram being congruent. Remember, I'm given that this is a parallelogram. Then the parallelogram must be a rhombus. So let's think of why that's true. So if I only know that this side is equal to this side, that must be a rhombus. You say, well, wait a minute, I thought both pairs of opposite sides have to be a rhombus. Well, remember, this is a parallelogram, isn't it? So remember, the opposite sides are equal to each other. So if this is 1 tick mark, that has to be 1 tick mark. If that's one up top here, then this one down here has to be 1. Look what it is now. All 4 sides are equal to each other, so guess what it is? This is a rhombus. Anytime you have a quadrilateral with 4 equal sides, that thing must be a rhombus. Well, I thought I was going to go on to something else, but that's about it. Okay, so hopefully you have a good understanding of what a rhombus is. Remember, a rhombus is a special type of a parallelogram that has 4 sides equal to each other. All right, we talked about squares as well, so that should cover it. All right, good luck with that lesson.